To a video for section 12.7 that is looking on the discriminant. This is part 2 of a section that looks at the quadratic formula. So to begin with, let's talk about what the discriminant is. The discriminant is the expression that's under the square root in the quadratic formula. Specifically, it is b squared minus 4ac. So it's the part of the quadratic formula underneath the square root, this thing. Okay, so let's talk about the a, b, and c, which are the same a, b, and c you know from the quadratic formula. So the b here is the coefficient of the x term. The a is the coefficient of the x squared term. And the c is the constant term. And remember, if your equation is in standard form, it will be set equal to 0. So what does it help us do? It helps us determine the number of real number solutions that the equation ax squared plus bx plus c is equal to 0 has, also known as the roots. And if we're talking about the function, then we're talking about the number of zeros, the number that are real. So now that we've talked about imaginary solutions, we can see how these kind of apply. When you're solving in the quadratic equation and you get imaginary answers, it's because the discriminant would have told you that. Okay, so let's talk about how do we use it. So there's 3 cases. So let's go through each case individually. So the 3 cases are as follows. b squared minus 4ac, the discriminant, is greater than 0, which means it is positive. B squared minus 4ac is equal to 0 exactly. Or b squared minus 4ac is less than 0, which means it's negative. So in our first example here, a is 1, b is negative 6, and c is 7. So if we do the b squared minus 4ac, that'd be negative 6 squared minus 4 times 1 times 7. We figure out what kind of number we're going to get. That's 36 minus 28, which is 8. And that is positive. That's greater than 0. And so what that means is that when you take that square root, you're going to get 2 answers. Remember the plus or minus in front of the square root in the quadratic formula? That gives you 2 answers, right? It's negative b plus or minus in the square root, and there's the discriminant. And so that plus or minus gives you 2 answers. And so that means in the graph there's going to be 2 x-intercepts, and there's going to be 2 real solutions. Okay, so this is the first case. If it's positive, greater than 0, you get 2 x-intercepts, which are 2 real solutions of that equation. Okay, in the second case, when it's exactly equal to 0, let's go ahead and see what happens here. We get negative 6 squared minus 4 times a, which is again 1, times c, which is 9. We get 36 minus 36, which is of course exactly 0. And you could see from the graph that there is 1 intercept, or x-intercept right here, which is exactly where the vertex is as well. And so when we have it equal to 0, you only get 1 x-intercept, which means there is 1 real solution. Okay? What's happening here is that the solution is repeated. Alright, so then let's go ahead and do the last one. The last one here we got x squared minus 6x plus 11. And so a negative 6 squared minus 4 times 1 times 11. That gives you 36 minus 44, which is negative 8. Negative 8 is of course less than 0. And so if you look at where the x-axis is down here, that graph is not going to go through the x-axis at all. There are no x-intercepts. And so there are 0 real solutions. You could also sometimes, sometimes I've seen this described as there are 2 imaginary solutions. These are equivalent to each other, but be careful to say that if the question's asking how many real solutions, don't say 2. It's no real. Okay, so again, if it's less than, it's negative. You don't cross the x-axis at all. You get 0 real solutions. All right, and that's how you use the discriminant.